All right, let's get started. Welcome back to the series. Sorry for not streaming last Sunday, it being Easter. Spent time with the wife and did other things in real life, and work being so hectic. I just felt that was the better option than to try to rush to get a stream out that just, with everything going on. So we're back, and hopefully we could get more streaming done, get further ahead with this project. So I went ahead and built a board, a revision 2 board, ran through the test process. Let's see if I can find everything. So let's see here. Pop this open. Pop that open. Maybe. Okay. Well. Oh, LibreOffice wants to update. Yeah. Okay. Awesome. Wants to update while I'm trying to open up documents and stuff to show. So let's see here. I just want to give you a brief overview. If LibreOffice actually wants to load. I didn't realize there's an update. Everything's always got to update when you want to use it, Okay, so yeah, I finished getting the test plan pushed over to basically a document format. Pull off the pull this up here. Pull it off of the so let's go here. Main screen. Oh, all right. Yep. So put it into a document, regular document format. I have to go through and clean some of this up. That's fine. Most of it was just like spelling and stuff. So organized it, broke it all down, added all the new test points, updated the test log, and ran through it all. I have to go through and finish filling this out, but that's not a big deal. I'll take care of all that. Got a chance to use my new scope. Let's see here. So it was factory calibrated, but that would be only good for about a year, typically. So, but I'll just put that in there. So, boom. So the test log, the test plan, ran through all that, tested it. So now we have that. Get back in here. So we are still on 24. The RS-45. Everything works. So I was able to program. We're back at where we were when we left off last time, which is actually doing the main programming. To make sure we get our COM ports proper here. And the UART bridge just shows up beautifully. No muss, no fuss. No foul. So let me go over to the phone real quick. Yeah, I should not have mounted the board, but so version 2 with the pluggables pulled out further. The lid definitely closes on it much better. Definitely looks much nicer. So I'm happy with it. All the new test points are here. The newly added cap for filtering the analog voltage, the temperature sensor. It passed all the tests. The RS-45 interface works fine now. So we're on COM 7 for programming. So why aren't you Oh, VS Code wants to act up so hard. Had everything working. Oh, we're installing update. Okay, everything wants to update at the same time. LibreOffice wanted to update. Oh, please. Stop. Just update. 30, 40%. Okay. While we're waiting on that. So let's go here. All right. RS-45. Now, we know that's wrong. But it's at least changed. Sorry, I'm coughing. The weather changing. Oh, are you serious? Click to restart. Let's try that again. We're gonna kind of change some of that text to shorten that a little bit. Are you not gonna start up VS Code for us? Are you not gonna come back up and work properly this time, please? Please, VS Code. Oh, go. What? What? Oh my god, I had to go through that. Oh. No, it works. Okay. I don't know why it got upset. Okay. COM7 is correct. So we're here. Let's make sure. Let's just delete the build directory. Make sure we can build and flash. Oh my gosh. Here's putty. So this is on the RS-45. We'll probably end up over time mimicking the RS-45 or kind of come up with two separate consoles, like the serial console for the debug port and then something separate for the RS-45. Who knows? Again, this is just, a dev kit. This is going to be example firmware to show you how, to interface with the different components, the different subsystems. So it'll be, as polished as we could get it, but I'm not looking for super perfection because the whole idea is for learning and teaching. And experimenting. So obviously our temperatures are way off. But we are changing. So we are seeing numbers. I think the math formula needs to be updated for that. And that's fine. Let me get that hot air gun going here. Yeah, so we've actually got it changing. Now, again, so it'll be in Celsius, but we'll need to make sure our conversion is proper. Because once you get a conversion proper, yeah, once we get that proper, then we'll be able to figure everything else out. So I have a feeling it's in here. So right there, we got the temperature. What are we? Okay. Okay. Oh, okay. We're just reading the raw EDC value. Okay. All right, so let's make sure we can flash. Okay, the fan's gonna go crazy because there's nothing to keep it down. Boom, we're flashed over. Okay, good. All right. Yeah, the VS Code changes from the updates kind of threw me off a little bit because the windows look a little bit different. It's like they updated dark mode or something. So, okay, temperature. So we're just reading the raw ADC value. So let me pull. Don't really need that. Putty. Okay, so it should be room temperature. I need to go out and buy some 9 volts. Oh, so let me look at. I am so unprepared. Okay, so it's kind of chilly in my basement, my workshop right now. So average room temperature is around 18 degrees Celsius in here. Woo! So let's go back to here. Not read the raw value, but actually CFL build. I have to double check this. So we have our millivolts. Flash it over. Two degrees Celsius. Okay. So, average voltage. Okay, what is temperature? It's a float, so we should be able to do a negative. Okay. Something's wrong. I don't think it's looping properly. Yeah, it's not changing at all. So, what is voltage value? Okay, out voltage. Okay. All right, so that's the first problem. Probably gonna fail. Okay. Voltage. So that is an int. And then what's voltage value? Oh, that's an int as well. Why did you complain? Oh. Okay, you had a complaint, and I can't see what your complaint was. Okay. So, voltage. Okay. Just for debugging, we're going to build that. Get out of my way. Oh, well, wait a minute. So should it be at? Makes sense as you're from pointer. Fix it. Get rid of the error. We'll cast it. Let me see what it should be. Pushing that. All right. Why is it that changing? Let's. Okay. So obviously I'm doing something wrong because. All right. ADC calibrate voltage. Calibrated voltage in millivolts. Voltage. Oh, wait a minute. ADC calibration handle. ADC raw data and out calibrated ADC voltage. So I am obviously doing something wrong here. So what we're going to do is figure this ADC cali. I'm sure there's a hello. Do not copy. Let me see if I can understand this. Because there's something I'm doing wrong. That should be changing. All right. All right. So, ADC Kali handle. All right. Let's kind of let's give that a new. Okay, let's see here. LE ADC Kali curve fitting. Okay, we're doing line fitting. ADC unit 1, right? Unit 1. Okay. Okay. Kali handle. All right. All right, ADC. All right. Okay. Maybe we don't need to do that. Let's get rid of that. See if this changes anything. No, we have numbers changing. No. Okay, heat is raising it. Okay. We got something going on, yeah. Okay. So that's like 800 and some millivolts. Okay. Since we're not doing any kind of rolling average, let's try to figure this out. So we've got 800 millivolts. Okay. Let's silence that. Because that's going to annoy us when we try to do a get temp. And we're going to see if we can get this average voltage, if that'll work. All right. All right. Please count to full. Sum minus buffer index. Okay. I think something's wrong here. So what we're going to do, we're just going to get rid of this. We're just going to voltage value. So we're not going to be looking at the rolling average. I just want to see if it's going to work here. It's 2. Okay, something's wrong with this calculation. Let's see here. Oh. Something is definitely wrong. Let's see if we get, if it's at least going to get the current millivolt value. Let's slash this guy over. And I think something's wrong with the math. Let's see here. Okay. Okay, we're at 740. Okay. And I don't have. All right, super controller, hardware. Do I have? We have the PDF. Let's get the data sheet for that. Temperature sensor. Because. All right. Okay, it is TMP 36. GRTZ. Wheel 7. Yep. Pull the data sheet on that guy. Because I don't, my stupid idiotness probably. Huh. Helps if I have this working right. Okay, all right, data sheet. Let's go back here. And we have the 36. All right. Okay. Okay, so we're 750 millivolts at 25C for so I have a scratch pad. Math is not my best subject, so I apologize. So 25C. So okay. 10 millivolts with a 10 millivolt per C division. I knew I was missing something here. All right. So if it took, let's first see here. Let's see here. So 0C. So if we want to get, let's say we want to assume we're at 0 degrees Celsius here. Okay, 25, it's 250, not 500. Okay. Values, we're gonna hide this. We don't need this anymore. To try you. 250. Because at 25 times 10 millivolts, 250. So that would get us down to 0 degrees Celsius. No. My brain likes to hurt. You know what? Let us ask. All right. Let's see. Okay. Oh, okay. Okay, so based off that, that's what Copilot says. So let's oh. We'll see what happens. Right. Oh. Flash. See what that does. When in doubt, ask AI for help. Huh. Okay, it's saying 23.6. 24. Okay, which could be correct given where it is. Because it's on the PCB right next to the motor driver, it's going to more likely. Because if we can get this solved, this part going right, yeah, get my temperature sensor in here. Come on, meter, wakey. Okay, well, the ambient room temperature is about 19.3 degrees Celsius. Well, and according to the thermocouple, we're about 23 degrees Celsius on the board by the chip. And that's saying 24. I'll take it. I mean, 1 degree Celsius off, considering I'm using a low-cost thermocouple that I picked up off of Amazon. All right. So Okay. All right. That's promising. Thank you, Copilot. Turn on the hot air gun. Oh, we've got changes. All right. All right. All right. All right. All right. Okay. Now. Okay, I will accept this. We have values changing, and I am more than happy to work with that. And it matches relatively closely to what I was saying on the thermocouple. Degrees Celsius, I'm not going to split hairs over. So for now, okay. Now let's see. I mean, do we really need... Oh, no. All right. I don't know if we really need this because it's not like it's... Yeah, we're not going for super precision. So let's go ahead. We don't need a rolling average. Let's see if we can clean this up and get rid of stuff. Let's make this as simple as possible. All right. Okay. There we go. Let's go and clean this out. Gonna see if it builds. We'll clean this up a little bit more, get rid of some of the junk variables and stuff we're not using. Because why? All right. We're making progress. Perfect. I will take it. All right. So get rid of you. Okay. Don't need that. Yes, yes. No, no, no. Yeah, let's just clean all this up. Here we go. Init, monitor task. All right. We're not going to flash again. We're just going to make sure it builds. So, okay, we don't need this. Oh, and we're at unit 1. Make sure we build. Good. Clean code. So now we've got that broken out as a task. All right, perfect. All right, so PWM fan. All right, so we're going to use the system status so we don't need that, mainly because we need to make sure we grab that temperature value. So We've got the 3x, the temperature header, which will let us use this float. Let's make sure. Yep. 3x 10. Okay, yeah, that's that way we can call it. Okay, so we have the temperature that we can pull into the system status. So it's going to be a system that monitors things. All right. Wow. Does not equal 0. So this is going to have to be fleshed out quite a bit. All right, so we don't need this. Are we pulling? Okay, so we're pulling the fan. Sorry, I have to keep muting myself. Again, the temperature changes. I don't want to be coughing in your ears, you know. So what we're going to do, all right. So let's kind of define fan on temp. So we're in Celsius. So we want to turn the fan on. Right now we're just going to fan on low temp. So let's go. I'm going to go and pull up the data sheet for the stepper. My bad. The stepper controller. My mind's getting ahead of where I'm actually at. So what I want to do is, here. I'm going to pull this over to the main screen so we can look at it together and enjoy ourselves. So what we want to look at is recommended operating conditions. Okay, that's storage. So here we go. Yeah, degrees C per watt. Trying to figure out, I want to look at, okay, here's our thermal shutdown temperature. This is one of the things we want to look at here. Right here. Yeah, it selected all that. So that's when the system decides to shut itself down at. The minimum value, because everything's going to be, a range, it's a tolerance. So minimum value is 150 degrees Celsius is the temperature at which that chip, the driver chip, will just shut itself down. It'll go into thermal shutdown. So what we're going to want to do then is definitely keep it well below that. We want to try to keep that guy as cool as possible. So hence the heat sink we threw in there and then the active cooling. Because it's going to be enclosed in a case, we definitely want active cooling to help keep that thing nice and cool. So if we're going to take the minimum temperature of 150 degrees Celsius in mind, so we want to kick on the fan. We want to put it like a lower idle speed. Let's say 40 degrees Celsius. The low. All right. So let's say we want to kick it on at 85.0. So that is the absolute warmest we would like it to reach before we kick that fan on. Because you want that wiggle room, for one thing, to give it time to come down in temperature. And mainly to give it time to come down in temperature. Because it's not going to be an instant thing. That way your system can still operate within that little window while it's cooling itself down. So we're going to say we want to, so that's our fan on high temperature. Now we could define our PWM values if we really, really want to. Int fan low speed. So what we can do is we can go over to here. Do I not have that? Do we not have that? Oh, fan get. I think it's fan get. No. What is it? I don't have that in there. Huh. Well, I'm done. All right. Let's clean this up. Yeah, let's shorten that. Fan. All right. So I think I've got that in the New York console. There we go. Actually, fan set. So let's see here. Fan get. All right. Fan set. Yep. Okay, so I copied and pasted that twice. Sorry. Okay, fan get, fan set. Clean you up. We'll clean this up. So RS-45. Send. So that should work. Let's build it. Flash it. No. Why are you? No. No. Why are you mad? I did something wrong. System status. Let's see. Oh. Yeah. Well, that would definitely make it mad. Let's see if. Because I kind left that in the lurch. I'm not putting anything there. Woo! I'm a programmer. I can program. So now we should be able to. Okay. 30. Oh, beautiful. All right. So we'll say 50% and 100%. So we'll go 50. There we go. Bam. All right. So now we've got the fan. Perfect, perfect, perfect. Beautiful. So what we're going to need to do is we're monitoring all this. So basically here, so that just monitors the status byte. So now we need to if temperature less than fan on low temp. I think we just do fan set. We just copy the. Yeah. Fan set. Fan low speed. Okay. Fan temperature is less than Oh no. No, greater than. Greater than. Sure. Less than. High temp. Okay. Sure. Less than. Temp. Okay. Probably a better way of doing this. Sure. Greater than. High temp. So it should walk through this. Now we'll figure out a routine for updating the status byte. And that'll be for the we're going to be monitoring that temperature or that fault GPIO. Again, it's not going to be a it's not going to tell us exactly what faulted out, but it'll help us. Flash. All right. So the fan does kick on while we're flashing it. Okay, so fan's off. Okay. So we're definitely below the. So I'm gonna start heating up the chip. Fan comes on, goes off. Let's see if it'll. I mean, we're only pushing it like 100 degrees. Trying to get the. There we go. There we go. There we go. I got the kick on full blast. Doesn't stay on long because the board does sink a lot of the heat away real quick. And then if the fan's blowing directly on the chip, directly on everything. Turn this guy off. And the fan. Okay. Little bit of starts and stops there, I guess, while the temperature kind of equals out. We might have to kind of put a... what we can do here. So what happened was the fan, as it hit this right here, fan on low temp, we're going to minus 10 degrees from it. That way it gets well below so even though the low temp is like, what would I say, 50, 40, it'll wait till it hits 30 degrees Celsius before it shuts off the fan. And then it should stop that errant restarting the fan because everything's balancing back out. But this is good positive news because the fan's working. That means the temperature sensor is working. Let us make sure that let's go back over the phone. Let's get that thing moving here. Motor speed. Get that guy moving. Clip, clip, clip. All right. And what's cool is while that's running, I've been kind of checking. Nope. The board is slowly warming up. Not by much. It's not going up very fast. Now, mind you, this is a smaller stepper motor. The larger guys will draw more current, which would heat it up a little faster. Plus, they're not enclosed. Plus, the workshop is nice and chilly. Yep, we're going up in temp here. Nice. Nice. Again, we're not looking for super precise temperature measurements. We're just looking for set points. Even, like your home thermostats, it's going to be a degree or two off at set points and stuff. So this is perfect. So yeah, moving to ADC Unit 1, solved all the timing problems. Now all this stuff's working right. So one of the things we'll have to do is... So one of the things I want to do real quick, are we... COM21. So what we're going to do is putty low 21. We're going to open that. So this is the standard UART port. That is the debug port. So let's go back to here. I just want to show you it works. Go over here. So that'll be this guy right here, the FTDI header. So I just wanted to show you that that works. Everything's working so far. Let's see if we can get a status trip. All right, so we've got a status trip. Resetting is going to be a little bit more difficult. Yeah. Now I think. See, that's cool. That's cool. That's what we want. Let's see. So that. Okay, so we reset the status set to 0. Oops. Okay, so that's not really triggering it to force it to 1. But it's fine. I'm not going to argue with it for now. Not being able to force an error like that where we can force the error this way. And then re-enable. Okay, perfect. Windows, stop it. Perfect. Because what I want to do is, because I wanted to test the FTDI header, is one of the things I'm going to want to do is, obviously pull this, continue working the RS-45, and get the shell put back together, get the lid, get the fan in the lid, and do some more, and start developing and do further testing with it like that. Because technically we don't need the lid open to continue our development. And this will help, test the fan system and everything else. Oh, this is, we're getting close. Oh, I closed the wrong session. 24. Load 24 for the RS-232. Yeah, we're still staying around 35.5, 36 degrees Celsius. I might throw code in there to convert it over to Fahrenheit. Why? I mean, I might, just so you can see how it's done down the road. So right now the fan's not going to kick on, and that's kind of ideal. We don't want it to kick on. It's just awesome to see it get this far. So if we go back over to our main system. Nope. Get count. 152. Yeah, that's right. Every cycle. 153. Oh, I need to clean some of this stuff up. Sad has this bite? Yeah, I'll clean all that up. We'll clean all this stuff up. We'll go through and, make sure all our commands and stuff. Because we're getting to the point where sorry, your console, we'll probably add more to this. Here we go. Let's fix this while I'm here. All right. Does that still work? Yes. All right. What we might do then is kind of do some more expansion to this, clean things up. We don't really need the echo. Who cares about that? I think I left that in there. We'll go through, we'll clean this up, get rid of the junk we don't need, like the echo. We'll set up so you can use a question mark. Instead of typing in help. We'll set that up. So we got that. That we're pretty much done with. This we're done with for now. I mean, we might throw it, maybe I'll leave it. We might put in that Celsius to Fahrenheit. We might. That would be like an afterthought down the road because I want to flesh out the system status. That is going to be the primary thing I want to focus on. At least get something to be able to read the fault. Whether or not we can make something super useful out of it. And we'll want to be able to shut the system down in case of a fault. Basically turn off the motor driver and stuff. So we'll have to kind of work on that. But we're getting there. GPIO. Yeah, we'll be monitoring that that fault status. Now, before I go, let's check something. Let's go here. And I know I have to clean up all these licenses and stuff and clean up all these files and stuff for us. Do we have... Okay, we are monitoring the fault pin. I mean, so since we're monitoring the fault pin, we're mapping it here. We might as well go ahead and actually, maybe in the next session we'll update this to throw in a byte just to monitor that fault, or maybe a boolean. Probably just be a byte. You're going to take a boolean or a byte. You're going to take the same amount of memory, so I'll just throw in a byte. Basically, 1 or a 0. That's why I thought a boolean, just to monitor that fault pin. Because with 0 faults, it should actually be a high. So we can monitor that fault and add it to like the RS-45 console to say, hey, is there a fault? So we're going. So we've got the driver in here. We'll probably want to pull that into here. You know, I'm going to do that real quick before I. There. That way we can pull from that. That way we can expose that that fault condition to outside. But we'll take care of all that. I'll tell you what though, this printed TPU belt, it's going on pretty good. I'm happy with it. I'm really happy with it. All right. Well, kind of a slightly extended video, and mainly because I got excited that we've made this much progress. We're doing pretty darn good. And I'm really happy about it. So I think what we will do is, again, call it here. And we'll get back with you, hopefully, sooner than later. Hopefully we can maybe Saturday or something. I'll do what I can, see how busy I am throughout the week. But thanks for hanging out with us. I really appreciate it. And have a good rest of your afternoon.